Let's do Brahmanad. Om. Om. Santi. 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 Swastha. Dear student, previous class I discussed about the introduction of group 16 element, occurrence of group 16 element, general trend in properties of group 16 element, anomalous behavior of oxygen, difference of oxygen with the other elements of group 16. Now I will discuss about the dioxygen. At first, I will discuss about the preparation of dioxygen. Now I will explain about the laboratory method of preparation of dioxygen. First method is from chlorate, nitrate and potassium permanganate. When chlorate, nitrate and permanganate undergoes heating, then dioxygen is formed. Suppose I will take potassium chlorate. When potassium chlorate is subjected to heating in the presence of MnO2, then potassium chloride and oxygen is formed. Similarly, I will take an example of nitrate. Suppose I will take potassium nitrate. When potassium nitrate is subjected to heating, then potassium nitrate and dioxygen is formed. Similarly, I can take an example of permanganate. Suppose I will take potassium permanganate. When potassium permanganate is subjected to heating, then potassium manganate is formed. Also here dioxygen is formed. Also here manganese dioxide is formed. Next I will discuss about the second laboratory method of preparation of dioxygen from oxides of heavy metal. The oxides of heavy metal like mercury, lead, silver, when subjected to heating, then dioxygen is formed. Suppose I will take an oxides of mercury, HgO. When HgO is subjected to heating, then Hg and oxygen is formed. Similarly, suppose I will take an oxides of lead, Pb3O4. When Pb3O4 subjected to heating, then PbO and oxygen is formed. Similarly, I want to take an oxides of silver, Ag2O. When Ag2O is subjected to heating, then silver and oxygen are formed. Next laboratory method of preparation is from hydrogen peroxide. When hydrogen peroxide is subjected to heating in the presence of nickel and manganese dioxide, then water and dioxygen are formed. Next laboratory method of preparation is your electrolysis of water. When water undergoes electrolysis, then hydrogen and dioxygen is formed. This is all about the laboratory method of preparation of dioxygen. Next I will discuss about the commercial method of preparation. In commercial method of preparation, air free from carbon dioxide and water is subjected to liquefaction. Then by following the dry distillation, dioxygen can be prepared. The dioxygen left over boiling point 90 Kelvin. These are the method of preparation of dioxygen. Next I discuss about the properties of dioxygen. At first I will discuss about the physical properties of dioxygen. Dioxygen is a colorless, odorless, tasteless gas. It liquefies at 90 Kelvin and freezes at 55 Kelvin. Dioxygen is paramagnetic in nature. The stable isotopes of dioxygen are O16, O17, O18. These are the physical property of dioxygen. Next is your chemical property. First is your action with the metal. Except platinum and gold, oxygen can react with the other metal to form corresponding oxide. For example, sodium plus oxygen gives the sodium oxide. Aluminium plus oxygen gives the aluminium oxide. Next chemical property is your action with the non-metal. When dioxygen subjected to reaction with the non-metal, then corresponding oxides are formed. Suppose I will take n non-metal, that is your carbon. When carbon subjected to reaction with the oxygen, then it gives carbon dioxide. Similarly, when phosphorus subjected to reaction with the oxygen, then phosphorus pentoxide is formed. Next I will discuss about the reaction with the compounds. Suppose I will take in compound sulfur dioxide. When sulfur dioxide subjected to reaction with the oxygen in the presence of vanadium pentoxide at 720 Kelvin under 2 atm pressure, then sulfur trioxide is formed. Similarly, when HCl is subjected to reaction with the oxygen in the presence of calcium chloride at 700 Kelvin, then water and chlorine gas are formed. Next I will explain about the uses of dioxygen. Dioxygen is an essential component for respiration. Dioxygen also used in hospital, high altitude mountaineering, liquid dioxygen and hydrogen is used as a rocket fuel. Next use is used in oxyacetylene torches which provide temperature for cutting and welding. These are the uses of dioxygen. Next I will explain about the classification of oxides. The oxides are classified into two types. One is simple oxides, second is mixed oxides. Simple oxides are the oxide in which the element other than oxygen present in the compound exhibit a single valency. Simple oxides are classified into four types. Number one is your acidic oxides. Number two is your basic oxides. Number three is your neutral oxides. Number four is your amphoteric oxides. The oxides which dissolve in water to form acid is called acidic oxides. For example, non-metallic oxides like SO2, Cl2O7, CO2, N2O5, etc. Some oxides of metal in higher oxidation state also shows acidic nature. These are Mn2O7, CrO3, V2O5, etc. These are the oxides of metal in which the oxidation state of the metal is higher. Similarly, the oxides which dissolve in water to produce an base are called basic oxide. The examples of basic oxides are Na2O, CaO, BaO. Usually, metal oxides are basic in nature. Next is your neutral oxide. The oxide which are neither acidic in nature or basic in nature. Such oxides are called neutral oxide. For example, water, carbon monoxide, nitrogen monoxide, N2O. These are the example of neutral oxide. These are not acidic in nature or not in basic in nature. Some metal oxides exhibit the characteristics of both acidic as well as basic oxide. They are known as amphoteric oxide. Examples of amphoteric oxide is your Al2O3, ZnO, next is your PbO, etc. Look at that, in all these oxides, the atom other than oxygen shows a particular valency. So these are considered as simple oxides. On the other hand, if I want to think about the mixed oxide, then the mixed oxide is made by two simple metal oxide, where the metal exhibit in different oxidation state. This type of oxide generally exhibit both the characteristics property of metal oxide. For example, Pb3O4, it is a mixed oxide. It is made by two simple metal oxide. One is your PbO2, another is your PbO. Here we take two PbO2 and one PbO. By the help of two PbO2 and one PbO, we can able to form Pb3O4. Here the Pb3O4 shows both the characteristics property of PbO2 and PbO simultaneously. Similarly, I can take another example, Fe3O4. This is an mixed oxide which shows both the characteristics property of FeO and Fe2O3 simultaneously. Similarly, I can take another example of mixed oxide, that is Mn3O4. This mixed oxide shows both the characteristic property of MnO and Mn2O3. This is all about the classification of oxides. Next I will discuss about the ozone. At first I will discuss about the preparation of ozone. Preparation of pure ozone is very difficult. There are two types of ozonizer for the preparation of ozone. Number one is Simon ozonizer. Next I will discuss about the principle of preparation of ozone by Simon's ozonizer. When dry and pure oxygen is passed to a silent electric discharge through a ozonizer, then partly the oxygen is converted into ozone. I can write the reaction like this: 3O2 silent electric discharge, temperature is 0 to 15 degrees centigrade, then ozone is formed. Next I will explain about the description of Simon's ozonizer. The Simon's ozonizer consists of two coaxial glass tubes, and the two glass tubes are fused together. The inner side of the inner tube and the outer side of the outer tube are coiled by tin foil, which are connected to an induction coil which provide high voltage. The high voltage current should be sparkless for the better preparation of ozone. When a current of pure dry oxygen is passed through the annular shape of Simon's ozonizer, then ozonized oxygen is formed. Next I will discuss about the conditions for better yield of ozone. What are the conditions for better yield of ozone? Point 1 is pure and dry oxygen must be used. Next point is the electrical current should be sparkless. Next point is the Simon's ozonizer should be in dry condition. Next point is low temperature, that is 0 to 5 degrees centigrade must be maintained. These are the conditions for better yield of ozone. Next I will discuss about the purification of ozone. The ozonized oxygen is subjected to purification by fractional distillation. In this process, the ozonized oxygen is subjected to cooling with the liquid air. At this condition, the ozone condenses to deep blue liquid while oxygen remains as gas. Now pure oxygen is obtained by fractional distillation. This is all about the Simon's ozonizer. Next I will discuss about the Brody's ozonizer. The Brody's ozonizer is similar with the Simon's ozonizer. There is only difference in the construction. At first I will discuss about the principle of formation of ozone by Brody's ozonizer. When silent electrical discharge pass over pure dry oxygen, then ozone is formed. I can write the equation like this: 3O2 silent is 0 to 5 degrees centigrade. Next I will explain about the description. This ozonizer consists of two coaxial glass tubes which are fused together. Here a beaker is present. This is your beaker. It carry dilute H2SO4. This is your inner tube. The inner tube also filled by the help of dilute H2SO4. Here two electrodes are present. The two electrodes must be platinum. This is your one platinum electrode. This is the other platinum electrode. The other platinum electrode also dipped in the dilute H2SO4 which is taken in beaker. Next I will discuss about the condition for better yield of ozone. This is also similar with the condition for better yield of ozone in case of Siemens ozonizer. First point is your pure and dry oxygen must be used. Second point is your the Brodis ozonizer should be present in dry condition. Third point is your electric discharge should be sparkless. Fourth point is your a low temperature, that is 0 to 5 degrees centigrade, must be maintained. These are the conditions for better yield of ozone. Next I will discuss about the purification. The purification process is also similar with the purification process of ozone in case of Siemens ozonizer. The ozonized oxygen is purified by fractional distillation. In this process, the ozonized oxygen is cooled with liquid air. At this condition, the ozone condenses as deep blue liquid and the oxygen remains in the container. Now the pure ozone is separated by fractional distillation method. This is all about the Brodis ozonizer. Next I will discuss about the properties of ozone. At first I will discuss about the physical properties of ozone. First point is ozone is a pale blue color gas with a pungent smell. Second point is ozone is diamagnetic in nature. Third point is ozone is poisonous in nature. Next is it is 1.5 times heavier than air. Next point is it is soluble in organic solvent like CCl4, benzene, etc. These are the physical properties of ozone. Next I will discuss about the chemical properties of ozone. First point is oxidizing agent. Ozone acts as a good oxidizing agent because when it undergoes decomposition, then it gives a nascent oxygen and oxygen molecule. This nascent oxygen is used for the oxidation. Now I will some reaction in which ozone acts as a good oxidizing agent. First reaction is reaction with the metal. Ozone react with the metal except platinum and gold to form corresponding oxides. When mercury is subjected to reaction with the ozone, then mercury oxide and oxygen are formed. This mercury oxide stick to the glass. This effect is called tailing of mercury. Next reaction is reaction with the lead sulfide. When lead sulfide is subjected to reaction with the ozone, then lead sulfate and oxygen are formed. Next is reaction with the Ki. Ozone oxidizes Ki to iodine. I can write the reaction like this: Ki plus H2O plus O3 gives KOH plus O2 plus I2. Next is reaction with the HX. Ozone oxidizes HX to corresponding halogen. Suppose I will take a reaction O3 plus 2HCl gives O2 plus H2O plus Cl2. Next is reaction with the alkaline Ki. Ozone oxidizes the alkaline Ki to potassium iodide or potassium periodate. I can write the reaction like this: Ki plus 3O3 gives KiO3 plus 3O2. This is your said to be potassium iodide. Similarly, I can write other reaction for the formation of potassium periodate. The reaction is Ki plus 4O3 gives KiO4 plus 4O2. This is your said to be potassium periodate. Next is reaction with the H2S. Ozone can oxidize H2S to sulfur. I can write the reaction like this: H2S plus O3 gives H2O plus sulfur. Next is reaction with the moist iodine. Ozone can oxidize moist iodine to iodic acid. I can write the reaction like this: 5O3 plus I2 plus H2O gives HiO3 plus 5O2. Here 2 molecule of HiO3 is formed. Next is your reaction with the dry iodine. Ozone can oxidize dry iodine to tetra iodine monoxide, which is yellow in color. I can write the reaction like this: 2I2 plus 9O3 gives I4O9 plus 9O2. This is your yellow in color. Next is your reaction with the stannous chloride. Ozone oxidizes oxidizes the stannous chloride to stannous chloride. I can write the reaction like this: 3SnCl2 plus 6HCl plus O3 gives 3SnCl4 plus 3H2O. Next reaction is reaction with the ferrocyanide. Ozone oxidizes the ferrocyanide to ferricyanide. Suppose I will take a reaction K4FeCN6 plus O3 plus H2O gives K3FeCN6 plus KOH plus O2. Next reaction is reaction with the ferrous sulfate. Ozone oxidizes the ferrous sulfate to ferric sulfate. Now I can write the reaction like this: FeSO4 plus H2SO4 plus O3 gives Fe2SO4 thrice plus H2O plus O2. Next reaction is reaction with the potassium manganate. Ozone oxidizes the aqueous solution of potassium manganate to potassium permanganate. Now I can write the reaction K2MnO4 plus H2O plus O3 gives KMnO4 plus KOH plus O2. Next reaction is reaction with the moist sulfur. Ozone oxidizes the moist sulfur to sulfuric acid. So I can write the reaction like this: H2O plus S plus O3 gives H2SO4 plus O2. Next reaction is reaction with the phosphorus. Ozone oxidizes the phosphorus to phosphoric acid. So I can write the reaction like this: P plus H2O plus O3 gives H3PO4 plus O2. Next reaction is reaction with the arsenic. Ozone oxidizes the moist arsenic to arsenic acid. So I can write the reaction like this: S plus H2O plus O3 gives H3SO4 plus O2. Next reaction is reaction with the nitrite, sulfite and arsenite. Ozone oxidizes the nitrite to nitrate, sulfite to sulfate, arsenite to arsenate. Let me explain with the example. Suppose I will take sodium nitrate. When sodium nitrate subjected to reaction with the ozone, then sodium nitrate and oxygen are formed. Similarly, I will take an example of sulfide. Suppose I will take sodium sulfide, and the sodium sulfide is subjected to reaction with the ozone, then sodium sulfate and oxygen are formed. Similarly, I will take an example of arsenide. Suppose I will take sodium arsenide. When sodium arsenide is subjected to reaction with the ozone, then sodium arsenate and oxygen is formed. This is your sodium arsenate. I can write here sodium arsenate. This is all about the reaction in which ozone acts as a oxidizing agent. Now I will explain some reaction in which ozone acts as a reducing agent. Ozone reduces hydrogen peroxide to oxygen. Similarly, ozone reduces barium peroxide to barium oxide. These are the reactions related to the reducing character of ozone. Next chemical property is formation of ozonide. Ozone reacts with the compound which contain double bond to form a ozonide. Again, when the ozonide undergoes reaction with water in the presence of zinc, then aldehyde or ketone or both aldehyde and ketone are formed. Suppose I will take an example, that is your ethene. When ethene subjected to reaction with the ozone, then an ozonide product is formed like this. This is your ozonide compound. When this ozonide compound undergoes reaction with water in the presence of zinc, then formaldehyde is formed. Next chemical property is ozone acts as a bleaching agent. Ozone decolorizes the coloring matter. So I can write coloring matter plus ozone gives a colorless matter and oxygen. Next is depletion of ozone layer. Ozone rapidly reacts with the oxides of nitrogen. That's why depletion of ozone layer occur. I can write the reaction NO plus O3 gives NO2 plus O2. These are the chemical property of ozone. Next I will explain about the uses of ozone. First point is ozone used as a germicide for sterilization of drinking water. Next point is ozone is used for bleaching of silk, ivory, oil and wax. Next point is ozone used as a good oxidizing agent. Ozone is used for purifying the air. Next point is ozone is used in the synthesis of camphor and artificial silk. Next point is ozone is used for ozonolysis of unsaturated organic These are the uses of ozone.